All right, welcome to the video on 9.8 Day 1, Graphs of Equations of Linear, Quadratic, and Exponential Functions. Today we are going to compare the graphs and the equations of these three functions. So let's look at a linear function. When you look at a linear function, it looks like a line. And here are the key features that we want you to be able to determine what they are. The slope. Now the slope, remember you can pick any 2 points, nice points on the line, and just count rise over run from point to point. So it looks like our slope is up to right 1, up to right 1. Therefore our slope is 2 over 1, or just 2. The y-intercept is where the line hits the y-axis, and that is right here up at 0, 2. And then we want you to say, is the line increasing or decreasing? Well, if you look from left to right, you always look left to right, the line is definitely increasing, and we also would have known that because it has a positive slope. All right, so that's all you need to know how to say for a line. For a quadratic, it looks like a parabola. And that's a U, either a U facing up or a U facing down. And the key features you need to know how to find for a parabola are the vertex. Remember, that is the point, either the max or the min, the turning point where the graph turns around. And it looks like it is at the ordered pair 0, 4. Because it is at the top of the graph, it is a maximum. Now here's the hard part about a parabola. Is it increasing or decreasing? Well, it's increasing from here to here, but then once it hits the vertex, it actually starts decreasing. So we're actually going to have two different answers here. It's increasing when x is less than 0, and it's decreasing when x is greater than 0. And let me explain that a little more. Your vertex is at x equals 0. And notice to the left of that is where the graph is increasing, and left of 0 means x is less than 0. Now, again, since the vertex is at 0, if you look to the right of 0, that's when the graph is decreasing. So that's why we put x is greater than 0. And an exponential function, it's a curve. It actually looks like a plane taking off. So we'll write airplane. Looks like an airplane taking off. Could also be an airplane landing if it's a different type of exponential. This one is going up, so it is a growth. And again, if it's growing, it is increasing, so we're going to also circle increasing. So these are the things you're going to have to label on the graphs. Okay, so let's try some. So for number 1, it is obviously linear. And that's what we do first. Now, once you know what it is, we need to write down the key features. So for this linear graph, you're going to have to identify slope, y-intercept, and whether it is increasing or decreasing. Okay, so the slope. We're going to pick two points, and if we count, we're going down to right 1, down to right 1. So the slope is negative 2 over 1, or just negative 2. The y-intercept is where the line crosses the y-axis. That is up at 0, 3. And then it looks like the line is going down. It has a negative slope, so we're going to say that it is decreasing. And then notice I covered all three of these. All right, number 2, it is that airplane landing. This time it's the airplane landing. So that is an exponential curve. For exponential, we need to say growth or decay, increasing or decreasing. That's it. Well, this one is obviously coming down. It's decreasing. So it is a decay, decreasing. And lastly, number 3, that is our u. That is our parabola. So we're going to write quadratic. It's a quadratic function. For a quadratic, we need vertex. We need to say if it's a max or a min. And we need to say where it's increasing or decreasing. Okay, so the vertex is pretty easy to spot. It's the turning point right here. And that is at 0, -4. Because it's at the bottom of the graph, it is a min. And remember, it's increasing and decreasing. We have to find the two intervals. So since the turning point's at 0, it's decreasing here, and it's increasing here. So how do we say that? Well, to the left of the vertex, it's decreasing. So it's decreasing x less than 0. To the right of the vertex is where it's increasing, and right means greater. X is greater than 0. All right, so that's what you guys would have to do if we give you a graph. Identify those key features. On the back, we're going to do if we give you the equation. Can you do the same thing and identify those key features? So a little review here. A linear function is y equals mx plus b. The slope would be the m. The y-intercept would be the b, and then you would know if it was increasing or decreasing based on the slope. It would be increasing if m is positive, and it would be decreasing if the slope m was negative. All right, onto a quadratic function. Quadratic, y equals ax squared plus bx plus c. You guys know that one. To find the vertex, remember that formula? Negative b over 2 times a. And then remember you have to plug it back in to find the y value. So I'll write here. This is where you would plug x back in to find its y partner. Max or min and increasing, decreasing, you would have to look at a graph. So we'll just say look at a graph. And then an exponential function, the equation is y equals a times b to the x power. And to determine our key features, if b is greater than 1, it's a growth. If b is less than 1, it's a decay. And if it's a growth, it's increasing. If it's a decay, it's decreasing. It's all based on this number b here. Bigger than 1, growth, increase. Smaller than 1, decay, decrease. All right, let's try some. So same thing as the front, but now it's from an equation, not a graph. So number 1, I hope you guys can tell that it is linear because it is of the form y equals mx plus b. For linear functions, we need to identify slope, y-intercept, and whether it is increasing or decreasing. The slope is the m, so 2. The y-intercept is the b, so negative 3. And because the slope is positive, this line is increasing. All right, number 2. I hope you guys can tell that number 2 is quadratic. Y equals ax squared plus bx plus c. If it's quadratic, we need to find the vertex. We need to say if it's a max or a min, and we need to say if the function is increasing or decreasing. And for this one, I think I'm going to do it on the graphing calculator. I'm just going to do it all on there. So go ahead and type this in. You may need to pause the video while you get your calculator out. I think it's easiest to just do it right on here. Hit graph. Okay, to find the vertex. Well, first of all, we can tell it's a min. So why don't we do that part? It's a min. And then actually I'm going to put this over here. To find the vertex, we do second trace, option number 3, because it's a min. And then do you guys remember we get the blinker to the left of the vertex, we get the blinker to the right of the vertex, and hit enter twice. The vertex is at negative 0.3 repeating, comma, negative 0.13 repeating. Okay, it's a min, and now we need to determine the intervals where it's increasing or decreasing. So if the vertex is at negative 0.3 repeating, left of that it is decreasing. So decreasing, we're going to say x is less than negative 0.3 repeating. And to the right of the vertex, it's increasing. So for increasing, we say x is greater than negative 0.3 repeating. That was kind of a tough one. And lastly, number 3 is an exponential. It's of the form y equals ab to the x power. For exponential, all we have to say is growth or decay, increasing or decreasing. And it's all about that b. If b is, we said, greater than 1, it's a growth. If b is less than 1, it's a decay. 1/2 is definitely less than 1. So it is a decay. And if it's a decay, that means it's automatically decreasing. All right, thank you guys for watching, and we'll do an activity to practice tomorrow in class. Thanks.